Welcome to this deep dive session for COPERT. My name is Annette Ehlert. I'm a technical product manager at the PTV headquarters in Karlsruhe, Germany. Today I would like to introduce you to COPERT in Visum. What can you expect from today's sessions? First, I would like to give you some background information and answer the questions: what is COPERT and why did we integrate COPERT? Then I will demonstrate how to use COPERT in Visum using our example network, the transport model of Halle. So let's start with the first part. COPERT stands for Computer Program to Calculate Emissions from Road Transport. It is a software tool that uses vehicle population, mileage, speed, and other data to calculate emissions and energy consumption. It is widely used by the industry, public authority, as well as academic institutions. COPERT and the underlying database are developed and maintained by misia on behalf of the European Commission. The COPERT methodology is consistent with European guidelines and allows for a transparent and standardized approach. The underlying database includes hot and cold emission factors for more than 800 different vehicle strata. These vehicle strata fall into 5 different categories: passenger cars, light commercial vehicles, heavy-duty trucks, buses, and a so-called L category. Based on this detail, vehicle strata fleet compositions per category are provided by year and country. Emissions can then be calculated using the traffic volumes and speeds from the assignment. The outputs include energy consumption, greenhouse gas emissions, as well as various air pollutants. So why did we integrate COPERT? Since more than 10 years, we support HB-IFA and Visum, a similar tool as COPERT. But as you can see from this map, HB-IFA is used in some countries only, and most countries in Europe use COPERT or a COPERT-based approach to calculate emissions. So COPERT is the standard EU vehicle emissions calculator, now also supported in Visum. So now let's have a look into Visum and the use of COPERT in Visum. You will see how the COPERT data are integrated into Visum. We will use the COPERT data to define fleet compositions that are associated with the demand segments in our model. We will calculate link-based emissions and aggregated outputs. Some examples of how the results can be displayed and extracted are given. And finally, we will set up a scenario management project with 3 scenarios. The 3 scenarios include a base year scenario for 2024, a future year, 2030, and a future year do something scenario. In this scenario, we assume that the bus fleet is replaced by electric buses. So the third scenario is also an example of how you can use your own data to calculate emissions. So let's switch to Visum. So here we see our transport model of Halle. We have already calculated an assignment, and we did also calculate the POT operating indicators to obtain the number of bus services on links. Now we see how the COPERT data are integrated in Visum. We first look at the vehicle strata. There are 875 vehicle strata. They fall into 5 different categories, and if we add here the count, we can see how many vehicle strata belong to a certain category. So other characteristics of the vehicle strata are the segment or size, the fuel type, and the emission standard. We now look at the emission factors that are stored for each vehicle stratum. The emission factors are provided by speed class and by gradient for subcategories. So other data that COPERT provides are the fleet compositions. So there are fleet compositions for the 27 EU countries by year, ranging from 1990 to 2050. We now filter fleet compositions for the current year 2024 and see one fleet composition for each category. So our next step is to define compositions that resemble the mix of vehicles in our demand segments. So we start here with the fleet compositions for the demand segments car and car extern. So here we see the COPERT fleet compositions, and we first select the year of our base model, that is 2024. And here I select 3 COPERT fleet compositions, namely the passenger cars, light commercial vehicles, and the L category. And then I define the shares to meet the vehicle mix in the 2 demand segments. There are mainly passenger cars, nearly 20% of light commercial vehicles, and a small proportion of vehicles of the L category. We do now the same for the other 2 demand segments. I create user-defined fleet compositions for HEV, and that corresponds to the COPERT fleet compositions for category heavy-duty truck for 2024. And finally, I repeat the process for demand segment bus. Also here, the mix of vehicles of the demand segment corresponds to the COPERT fleet composition for buses of the year 2024. So now I have defined 3 fleet compositions that I can associate with the demand segments in my model. So the next step is to add the procedure to calculate emissions. So we select here the corresponding procedure, COPERT-based emission calculation, and then the demand segments for which we calculate emissions. Here in the first tab, I can choose which outputs I would like to calculate. We now include the cold start access. We have here other groups for fuel consumption, greenhouse gases, and several air pollutants. In the second tab, we define for each demand segment an appropriate speed attribute. By default, it is a speed in the assigned network of the corresponding transport system. Then an attribute that represents the link volumes for each demand segment. And here we change the attribute for demand segment bus to the pre-calculated number of bus services for bus. So next we define an attribute that reflects the origin traffic for the calculation of cold emissions. In our model, we only calculate cold emissions for the demand segment car. Only trips of that demand segment start in the area that our model covers, and for other demand segments, the region traffic is set to 0. And finally, we need to associate the previous defined fleet compositions with the demand segments. Now all the parameters are defined, and we can calculate the emissions. When you execute the procedures, you will note a number of messages, and we recommend having a look to make sure that the inputs are defined correctly. And now we would like to display some results. In our model, there are also formula attributes. For example, some outputs are calculated per kilometer. Here we see the energy consumption in megajoule per kilometer. And all the outputs are also available for links and can be differentiated by warm and cold emissions, by demand segment or transport systems. The results can be further aggregated. For example, for territories, to view the results, the procedure for territory indicators must be added and then executed. And then we have various results for territories in this corresponding list. And now we have another look at results for NOx. It is also scaled for 1 kilometer of road, and we see also the results in the list. The emission statistics for the entire network can also be displayed. It contains vehicle kilometers by demand segment, various results for fuel consumption, greenhouse gases, and other emissions. And here in this list, we see now the selection of attributes that are calculated in our model. So now we start our scenario management project. We will evaluate 3 scenarios: a base year for 2024, a future year for 2030, and a future year do something for 2030 where we replace the bus fleet. So before I create a new project, I will add these 2 user-defined vehicle strata that replace the bus fleet in my future do something scenario to this base model. So I add these 2 vehicle strata, give them a name. The category bus is already selected, and we add the fuel type. These are different electric buses, and now I have to enter the emission factors for these 2 vehicle strata. So the emission factors for category bus must be provided by speed class and gradient. And for simplicity, we restrict our calculations to warm emissions and specifically to CO2 reported, NOx, and energy consumption. So that means we only enter warm emissions factors for these 3 pollutants. There are also emission factors only by speed class for other categories. These attributes contain general but no slope information, and you can see in the list which emission factors are needed. For category bus, emissions factors by speed class and slope are required. The factors with general are grayed out. So the corresponding emission factors for energy consumption for the 2 vehicle strata are prepared in this Excel file. They are available for different gradients and for the different speed classes. For the other 2 pollutants, CO2 and NOx, we assume emission factors of 0. And now all the emission factors are prepared in an attribute file that I now read here. So now our 2 user-defined vehicle strata have emission factors for the 3 different pollutants for warm emissions. And the last step before creating a project is to initialize all the results, so the assignment results, and there is also a procedure that deletes the results of the emission calculations that I add here now and execute. So we now set up our scenario management project. So create a new project and a directory and choose a name, emission calculation. And what we first do now is we define our 3 scenarios. So as mentioned before, we have a base year for 2024. We have a future model for 2030, do nothing. And we have a future model for 2030 as well, do something, in which our bus fleet is then composed of the 2 user-defined vehicle strata that I added before. So the difference between the 3 scenarios are the fleet compositions. The first scenario uses fleet compositions for 2024, the second for 2030, and the third scenario is similar to scenario 2, except for the fleet compositions for demand segment bus. So second, we define the modifications for scenario 2 and 3 by replacing the fleet compositions and shares within the fleet compositions. So we start here with the modification for scenario 2. And we go to the dialog with the user-defined COPERT fleet compositions, and we change the fleet compositions. We can see here the fleet compositions for 2022. They must be replaced by fleet compositions for 2030. We select the same COPERT fleet compositions and the same shares and remove the fleet compositions for 2022. And we do the same for HEV and bus. remove the previous fleet compositions, and for bus we edit the data, add the fleet composition bus for 2030 and remove the one for 2024. So our first modification is finished. And now we create the second modification for the third scenario. And for the third scenario, we use the modifications that we just created and change the shares within the fleet composition 2034 bus. So we assume here that our bus fleet is composed of the two user-defined strata. So we change the composition to custom, and then we can edit the weights. So we set the weights for system-based buses to 0, and for our two user-defined vehicle strata, we assume a share of 50-50. So now we have changed the fleet composition for demand segment bus. So next, we will allocate the modifications to the scenarios, the first one to the second scenario, and the third one to the third scenario. So our fourth step includes now the definition of some scenario indicators, which allow us to compare scenarios at the network level. We have here access to the emission statistics, and we will use 6 indicators. We will select here the fuel consumption total, CO2 reported total, and also for NOx total in the network. And in addition to these 3 indicators, we also select the emissions for demand segment bus separately, and we will use the same pollutants. So now we have on top the total emissions for the 3 pollutants and the bus emissions below. And here we can replace the rather long attribute names by some alias that are shorter and more visible in the table and meaningful. So I replace the attribute names. And the last one for NOx. So now we can see these scenario indicators as columns in the scenario tab. So they are on the right, and we have them here later to compare these scenarios. So now we add a procedure parameter. So we change the existing one because we would only calculate fuel consumption, CO2 reported, and NOx. So we will edit the existing one and reduce the outputs to the 3 pollutants. We also exclude the cold emissions and remove all the others. On the second tab, we do not need to change anything because the fleet compositions are changed. So now we will allocate that procedure parameter set to our scenarios, and now we are ready to calculate our scenarios. So now our 3 scenarios are calculated, and if that is completed, we will have a look at the scenario indicators that we can see here on the right. Maybe we change the units to have a better understanding of these indicators, and we can see here the reduction of the 3 pollutants from the first to the third scenario. So in case we would also like to have a closer look at the scenario results, we can also include some of the global layouts that we have previously used. So for example, for energy consumption by kilometer, for NOx by kilometer length. And we have another one where we can see results by territory. So these global layouts are then added to our project. And once I have done that, I can load a scenario. So for example, our third scenario, I will load the result file. And going back to the tab for global layouts, I can now apply the different layouts and investigate the results by the display in the network editor or in the lists. Yeah, and finally I have some display of indicators by territory. That was a short demonstration in Visum. Before ending the sessions, I would like to summarize the learnings from today's session. You have learned what COPERT is. You have learned how emissions can be calculated using COPERT in Visum. You have learned how you can use the data structures from COPERT in Visum to calculate emissions for fleet compositions that consists of user-defined data. And you have also learned how to compare scenarios with respect to COPERT output. I do hope you found the session useful and that it gives you an easy start with emission calculations in your projects. If you have questions, feel free to use the chat or drop us an email. And as always, we would love to hear about your applications. Have a good day and goodbye.